Hello everyone, today we are going to look at the circuit of a water tank full reminder. This circuit is mainly used to send out audible and visual reminders when the water level exceeds a certain limit. It mainly uses the switching characteristics of the triode tube and the 9300 series music chip we mentioned earlier as the sound source. Let's take a look at its working process. There is a headphone interface at the front of the circuit. Here is a water level detection composed of two metal sheets that are insulated from each other. After the power switch of one electrode of the circuit is closed, because the water level has not reached this electrode, the two electrodes are insulated from each other. So the base of the first triode is low level 0 at this time. Since the first triode VTG is an NPN triode, when the level of the base of the NPN triode is low, it is in a cutoff state. At this time, the positive electrode of the second triode will pass through this voltage. Resistor R2 provides a high level E for the second triode VT2. Then the second triode is also an NPN triode. So at this time, the second triode VT2 will conduct because its emitter is grounded, so at this time its electrode will become a low level. At this time, the base of the third triode VT3 is also at a low level. The third triode is also an NPN triode. At this time, VT3 is in the cutoff state, so the LED behind it and the 9300 music chip cannot get working voltage. When the water level overflows the detection motor, since the water is conductive, the two electrodes will be resolved, so the base of the triode VT3 is also low level. At this time, the emitter and electrode of the triode will become cut off. When the cutoff occurs, the ground square will become 1. Then at this time, the third triode will become conductive because its base has a high level. Then the positive electrode of the battery will provide working voltage for the following circuit through the triode VT3. At this time, the light-emitting diode will emit light. The 9300 music chip will emit sound through the speaker. In front of the third triode VT3, there is a resistor R3 and a capacitor C. Then its role it is used for delay. When the water level is full, the subsequent audible and visual alarm will sound. When the water level drops, its level state will return to the initial state. However, there is a capacitor here, so the charge on the capacitor C will not be released immediately. So at this time, even if the water level drops, the third triode will remain in a conductive state for a period. That is, the final working process of this circuit is when the water level exceeds the detection electrode. Then an alarm will be issued immediately. When the water level goes down, it will delay for a period of time and then stop the alarm. So for this circuit, we can change it into a simple timer circuit. The electrode in the front can be used for triggering. You can connect a button similar to a clear switch. H as a trigger. Then what about the machine pole of the triode behind it? By changing the value of the resistor R3 and the capacitor C, the turn-on delay time will be changed. Then this time when the switch button is pressed, the back circuit will form this delayed turn-off effect. This circuit is a circuit of a simple delay switch. When the front button is pressed, the back circuit will work immediately. Then when the button is released, the back circuit will work immediately. Then when the button is released, the back circuit will delay for a period of time and then stop working. Okay, today's video is here. Thank you for watching. Goodbye.